Chapter 12 is about simple linear regression. And for this chapter, we have three files: the PowerPoint file, the formulas PDF file, and the Excel shell file containing the problems that we will be working on in this chapter. Make sure that you download all the three files, print the formulas PDF file and keep the printed formulas by your side, and follow the lectures based on the PowerPoint file and work all the problems using the shell file. Now in this chapter, we'll learn what is a dependent variable, what is independent variable, and how to develop a regression equation for y based on x. And the regression equation will be like a straight line equation with a y-intercept and a slope, and those are called regression coefficients. B sub 0 is the y-intercept, B sub 1 is the slope. And then to do statistical analysis, okay, what are the assumptions needed, and how do you do statistical analysis, and how to do inferences, how to do estimation. These are the topics we'll be discussing in this chapter. Now let's go back to chapter 2 and 3, where we first introduced these concepts called scatter plot and correlation. Scatter plot and correlation are appropriate when you have two numerical variables. In chapter 2 and 3, we discussed visualization and summarization of data. And when you have two numerical variables, you can plot one variable on the x-axis and the other variable on the y-axis. And a scatter plot will show us the relationship that may exist between the two variables x and y. And correlation is a numerical estimation of that relationship between x and y, the two variables, two numerical variables. Okay, so let's look at an example. Suppose we have two numerical variables x and y, and if the points fall in this fashion. So you can see there is some kind of a linear relationship between x and y, and here along the straight line the y values vary a little bit more here than here. Okay. And here the y values are closer to the straight line. And then of course here the relationship is positive because the slope is positive, and here the slope is negative. So what we can say here is the relationship between x and y is linear, positively correlated here but negatively correlated here, and here the correlation is relatively less strong, and here it is relatively more strong. Whereas the graphs that we see here show us no linear relationship, but there is definitely a curvilinear relationship. Here it is concave and here it is convex. Now let's look at the strength of relationship a little bit more, and here again you see that these are positively correlated between x and y, strong and weak, negative correlation between x and y, strong and weak. Now let's look at these two graphs, and then you can see that no matter what x is, y seems to be the same value. So there is no relationship between x and y, but you can say that y has more variance here because the values are more spread apart, whereas here the values are within a tight range, so the variance of y is smaller. In either of these two cases, x doesn't have any influence over y, so the correlation is close to 0. So going back, we can look at correlation once again as a value between -1 and +1. Okay. And the sign of correlation gives us the slope of the relationship between x and y. So the correlation coefficient R will be a positive number in cases like these two. It will be a negative number in cases like these two. And the magnitude of R, closer to +1 or closer to -1, will indicate strength of relationship. Here in these two cases, the y's are very tightly packed together. So r will be here closer to positive 1, here it will be closer to the negative 1 side. Whereas in these two cases, r will be positive but it will be closer to 0, and in this case r will be negative value but closer to 0. And here r will be pretty close to 0, whether it is a positive number or a negative number, it really doesn't matter. It will be very, very close to 0. So to summarize, the strength of the relationship is given by the magnitude of the correlation coefficient, and the sign of the correlation coefficient tells us the slope of the relationship between x and y. Now this is the concept that we translate into linear regression.